Good morning and welcome to Flat Earth United. Joining me on this wonderful sunny morning is YouTuber Anthony Riley with some big news. How you doing, Anthony?
I'm doing all right, mate. It's not as sunny up here as where you are, though. It's overcast and getting ready to rain, I think.
But you've had enough good weather to produce some wonderful footage, though, have you not?
I have. The weather's been fantastic the last 24, 48 hours. I'm looking out the window right now and I can see fantastic visibility, but I've got a little bit of clouds. But I'm waiting to hopefully do some one last bit of footage before we leave, because I've realised that there's a bit of an issue that I've not noticed before, despite doing a lot of work on observations. And it's something that I'm pretty sure that most flat earthers do not know and do need to know, because it influences the results that we get.
Minor technical difficulties from Anthony there. I think he'll hopefully call us back in just a few seconds. There we go.
What?
Yeah, lost you for a second there. Can you summarise for the people who are watching now exactly what you told us on yesterday's, well, it was actually a test that turned into a hangout, but can you summarise what you found yesterday?
Right. Where I am at the moment, I'm overlooking the sea and I can see the wind turbines in the background. They're about 25 miles away. The problem with the wind turbines is I wasn't even looking at the wind turbines, but they're there. Yesterday, when I did the observations that I did, I could see the wind turbines on the horizon, but I could see the turbine, the hub where the blades attach. I could see the hub of the wind turbine sat on the horizon. So I'm looking at it and I'm thinking, that's a curve. The turbines they're 25 miles away. The hub of the turbine is 25 miles away. So, but I'm seeing the hub of the turbine on the horizon. So imagine looking at a wind turbine and you've got the horizon rising right up to the hub, and then you're only seeing the last third of the turbine. And I thought, oh my God, this is crazy. So I came home, I checked the footage.
You've missed a bit. So you were changing your elevation to create a. I don't want to lead you too much.
Remind me the bit that I've missed, though.
So
which is the bit I've missed?
Essentially were forcing something to disappear behind an obstruction by changing your elevation. Can you just detail that better than I did?
Okay. I noticed during the daytime, when it was low tide, that I could see the turbines on the horizon in full. Not in full, but I could see almost all of it. The bottom part of it was slightly obscured. Am I still here? Yes.
Yeah. I'm trying to get you to explain that you're on a ramp, basically.
Yeah, it's okay. But during the day when it was low tide, I could see, because there's a vertical aspect to the sea, I could see that the turbines were pretty much complete. I could see this with the naked eye. So I thought, well, I'll go home and I'll just double check it and I'll see what it's like at high tide. I went home and checked it, but I didn't do any of the recording because I just wanted to see what it was. But I could see virtually all of the wind turbines. However, when it came to high tide, because there's a vertical aspect in the sea, I could see that obviously the turbines don't move up and down with the water. The turbines are static, so the water moves up and around it. Sorry, I'm just getting interrupted. You have to bear with me while this phone call happens. One sec.
It's no problem. I mean, obviously, if you're a viewer, it's probably well worth checking out the what's the word?
I got it.
Is that the right word? You had a certain tone in your voice when you were explaining it yesterday that changed over the 2 or 3 conversations we've had since. But I don't know. I don't want to get
right. I'm back on. I'm back on it, right? So basically, when it was low tide, I could see the turbines were pretty much complete on the horizon, and they're 20 odd miles away, 23, 24 miles away. Okay, but I wanted to see what it was like at high tide, because on previous observations, I've noticed that when things are at high tide, when I'm looking at things that are miles away, the tide makes a difference on what we see. The swell makes a big difference, but I didn't know how much, and I didn't know how important the difference would be, because you don't normally have vertical aspects in the sea that you can measure with against the tide. But when I was looking at these things in the background, I had a peninsula of land and I had the turbines, And basically, there was a ramp that took me down to the beach, and it was a beach level. And this, where it takes me onto the beach, the sea comes right up to it at high tide. And I noticed that I could see a variety of different amounts of the land and the turbines simply by walking up the ramp and down the ramp, up the ramp and down the ramp. I could literally see the land disappear, and I could see the turbines dropping behind what you would not naturally presume was the curvature of the Earth. That's what you would naturally presume it to be. Now, I didn't have my zoom lens on me at the time. I only had my eyes, my own normal eyes, and I had a 200mm lens. So I got the footage from a 200mm lens, and I thought to myself, that's absolute proof that it's very persuasive evidence that it's curved. However, I went back and got the telephoto lens, the big zoom lens, because I wanted to see what was going on, what was actually happening when I was looking at it. I went back and I could see 25 miles with the zoom lens, and I could see there was a little band of that reflective band on the horizon, and it was literally blocking out the land. And what I was changing as I was moving up and down the ramp, I was changing the amount of parallax between the band of refracted, distorted stuff on the horizon and the land that was behind it. So I was directly changing the parallax of the opaque horizon against the land that was behind it. That's what I was adjusting. Now, to anybody else, I was walking up and down the ramp, but optically, to what I was looking at, I was changing how much of the land I could see and how much I couldn't do simply by walking up and down the ramp. So the issue then was, well, was that curve or was it not? And the answer is it's not curve, because I couldn't see with my own two eyes, and I couldn't see with a 200mm lens that which I could see at 5500mm. And then I could tell that there was a band of refracted light there that was stopping me from seeing it. So I thought, is that curve then, or is it some kind of optical thing? And it is an optical thing. But I only worked that out by having my zoom lens. So the problem was, if I didn't have really good zoom, say for instance a P900, if I had just a normal lens that was say 200 or 400mm, or my own two eyes, and I see things like the land dropping behind the horizon, I would naturally have walked away concluding that the Earth must be a ball, because based on the tools I had, that's the only information I could attain. When I applied the zoom lens to it, I could then see what it was that I was seeing to explain why it looked like the land was dropping behind the curve of the Earth. And it wasn't the curve of the Earth, it was just this atmospheric band of refraction on the horizon. And I was changing my parallax in relation to it and the land behind it, and I was directly adjusting that. But if you didn't have the zoom, you wouldn't have known it. So I guess the moral of that particular story is, when you're looking at things that are really far in the distance, particularly land, yes, it may look like it can go behind the curve of the Earth, but unless you get a zoom lens on it, a really good zoom lens, and zoom right into what you're looking at, you can't see what's going on. So you can interpret something as falling behind the curve of the Earth, but actually it's simply falling behind. You're adjusting the parallax between you and the atmospheric band of refracted whatever it is on the horizon, and the land that's immediately behind that. You're varying the parallax between the two. So I guess the moral of the story is, if you think you're seeing curve of the Earth, go and put a zoom lens on it, and then reconsider your position, because you'll get a different interpretation of what you see if you can see more, which is what the zoom lens will allow you to do.
Very cool. So, as you've said before, although it's not a P900, the telephoto lens rules the day. And ultimately speaking, you were out looking with your own eyes and looking with I don't want to say inferior camera lens, because the lens that you're actually using was superb. It's an expensive lens, but by the same token, it just doesn't have the zoom capability that a telephoto lens does, in the same way as a P900 does. And you describe it as a ball earth killer, the P900, even though it's not actually a P900 you're using, but the principle is exactly the same. You zoom in and you can see what's actually happening in that tiny band. Now, again, I'll lead you a little bit here. So when you explained it to me yesterday, you were saying that as you're raising your eye level, your amount of land that sits in that tiny band as your angle of attack on the horizon is increased, you're seeing more and more land condensed into a shorter and shorter space. Therefore, when you use a telephoto lens, you can actually increase that band and see what's going on in that area that yesterday you thought was something being obscured behind curve, but isn't.
This is the way I see it. When you stood at the beach and you got you literally, if you're dipping your toes in the water, you can see the water is at your feet. Then you're looking pretty much directly down. If we call the horizon 0 degrees, and you can look down to 90 degrees, which would be your feet. If you look at 45 degrees, that's where all the kids would be paddling and stuff like that. If you pick it up to 60, 65, 70 degrees, that's where you would see boats and stuff, jet skiers and stuff. If you pick it up towards 80 degrees, you're now looking out towards just below the horizon. And when you get to 85 degrees, you're going into no man's land because it's not clear what you're actually looking at, but you're looking really, really far away. Pick it up to 87 degrees and 88 degrees, and you're just about getting to the 90-degree mark. You're putting massive amounts of distance in a few degrees of your vision. You are compressing it all. You're squashing it into a blur. And when you do that, you can't pick out any detail without zoom. You have to zoom into it to zoom into that detail. Otherwise, you're just going to see blur, which is why you never see waves at the horizon. You only ever see waves up to a certain point, and then it just becomes a band of solid color because your eyes can't pick out the resolution. So going back to the wind turbines, when I was looking at the wind turbines at high tide, and I've got the hub of the turbine on the horizon, I would look at that and go, that's curvature of the Earth, because it's curved right behind the turbines. But when you zoom right into it and you can see what's going on, yes, the tide is right up to the turbine, the hub of the turbine. But when you see it at low tide and you see that the tide is basically at the bottom of the stem, you realize that what you're looking at is and you're seeing cresting waves as well. You're looking at it's basically the swell. You're looking at the swell of the ocean or the sea, and it's right in front of you, but you think it's 25 miles away. But the waves that you're looking at are in the foreground. You're not seeing the waves at 24 miles away and the turbines at 25.
Sorry to interrupt, but you explained yesterday really, really well why you know that the waves in the foreground are in the foreground. I know you've just used the word swell, but if you can explain how you've come to that conclusion.
Because when you can see on the footage that I've taken, which I'm going to do a live hangout tonight, you can see that there are individual waves that are making and breaking, cresting on the horizon, immediately obscuring the turbine that I'm looking at. Now, for them to be cresting individually, and you can see them up and down, you can see the individual triangles of each wave, you know that they are close to you. Because if they were that far away, they would be blurred, because you're looking 25 miles away and across all these waves. So you have to, logically, but evidentially, it's telling you that these waves are close. These waves are not far away. So when you're looking at something that's really far in the distance, that's essentially a pixel or two on the horizon, and you've got the waves, but the waves that you're looking at are clearly in the foreground, something, for whatever reason, is pushing the wave up in front of you. But it's to do with it's not that it's really being pushed up. It's just that the thing in the background is that small that it doesn't need to be much bigger at all than anything that's around you, because the thing on the horizon that you're looking at is literally a pixel. So you're getting something in the foreground that's bigger than the thing that's in the background that's tiny. And you're thinking initially, oh, it's curve of the Earth. But it's not. What it is you're looking at the waves in the foreground, or maybe in the intermediate ground, the middle ground maybe, and they are bigger perspective-wise than the little tiny pixel on the horizon. But unless you realize that them waves are right in front of you, they're the ones that are close to you, you're going to think, oh, that's curve of the Earth. Because I was pulling my hair out trying to work out what would be the flat Earth explanation for this. And the answer is the waves in the foreground are drowning out the waves in the structure in the background that is 1 pixel big. That's all it is. It's tiny. So what I'm going to do later on tonight, I'll do a hangout and I'll show some of the raw footage that I've obtained. When you see the raw footage, you'll see exactly what I'm talking about. But the reality is this: when you've got something that's a dot on the horizon and you always look up to the horizon, I know everyone says that no, technically it's down, but all the sea that you see leads you up to the horizon. When you see that little tiny pixel on the horizon and you change your altitude, what you're actually doing is you're altering the parallax of the waves in front of you and the waves in the middle ground, and they're bigger than the thing that you're trying to look at in the background. And that is truly what perspective really is. I know that scientists and heliocentrists say that perspective is a mathematical equation. Well, it may well be, but there's no maths for doing what we're doing. When you alter the parallax between something in the foreground with something tiny in the background, you can't do that with a mathematical equation. You have to see it with your own 2 eyes. You have to get your own evidences to show it, and then try and work it out yourself. And when you do that, you will go through it has to be a ball stage, which is what I had to go through yesterday. I was thinking, this is curve. How is this explained on a flat Earth? And the answer is parallax. You're changing the parallax of the waves in your foreground against the dot in the background, and you don't need to do much change to be able to do it. And it's really easily done. And I'm hopefully going to demonstrate it when I get in tonight. So with a bit of luck, there'll be a live hangout tonight with some really cool footage. And what ball earthers are going to be itching in chat to say, oh, look, it's curve, it's curve. And then when you really look at what you're looking at, you realize it isn't curve at all. It's parallax we're adjusting.
My favourite part of that story was the reasons you've come to this conclusion, because had you just had a flat earth hat on when you went to the beach or when you were out on your walk, you would have had your telephoto lens with you and you'd have immediately just started taking those shots like a flat earther would with the longest zoom lens you possibly have. But when you explained it to me, you were like, well, we weren't out with flat earth hats on, or you weren't. I know your wife's kind of agnostic to all this at the moment, but yeah, you were out to take pictures of the dogs, you know, so you've got your highest quality lens, not your longest zoom. And
indeed,
as soon as you've seen what you've seen with your own eyes, you've gone, I've got to start photographing that. I've got to get pictures. And of course, you're doing it with a lens that has led you to be able to demonstrate how this deception, or another part of how this deception's being perpetrated. Wonderful.
Yeah, I mean, just for any camera boss out there, she's got a Nikon D500. That's like a £2,000 body, and she had a 200 mil. It's a Nikon 200 mil lens that she uses for baby pictures and portraits and weddings, for stuff that's close up. That lens alone is £1,400. It's a lot of money. That's like £3,500 worth of kit, but it's designed for short range, close photography. And like I say, Nathan's absolutely right. We went down to the beach to play with the dogs because it was the beach time. It was recreational time, and the dogs were having a crazy minute, and we wanted to capture that. We had no preconceptions of flat earthness at all. But when I was walking down to the beach and I looked over to the horizon, I noticed this peninsula of land, and I walked down the ramp. I realized that land, when I got to the bottom of the thing, because it was so far away, when I got to the bottom of the ramp and I couldn't see it anymore, I had a eureka moment, and I thought, whoa, hang on a minute. So I went back up the ramp. I had another look to reconsider my position. This is just with the naked eye. Looked at the land. Went back down the ramp. Looked at the bottom of the ramp, and I thought, absolutely, that totally supports the curvature of the Earth, because the land disappeared. It didn't merge or converge with the horizon. It totally went. So I said, give me that camera. So we captured it on her camera with a 200 mil lens. There's not a lot of zoom to it. It's fantastic for showing shells on the beach and stuff like that, but it's no good for what I was doing. But I wanted to capture it because I wanted to show how, if you had the wrong kit, or if you had the kit that wasn't suitable for the job that you're doing, and you were relying on your own eyes and or your own lens that's a normal lens, it's not ideal for zooming, I would have got left there thinking it was absolutely a ball. But I came back, I grabbed the zoom lens, came back, and I did the same observation again, and I got the same results with my eyes. So I knew that the optics were similar. But then when I put the zoom lens on and I zoomed right in, and I could see what it was that was stopping me from seeing it, which I couldn't see with the naked eye. And it was this band of refracted light that was across the horizon. But because it's so far away, and it was only small, but the land behind it was flat from my perspective, simply by walking up and down the ramp, I was adjusting the parallax with the band of refracted light or band of distortion on the horizon with the land behind it. So it was like a seesaw. I was as I went down, then the land went down with me, because the obstructed the horizon refracted band of distorted whatever it is was literally the tipping point. I was literally on the crest of a wave, or they would argue the curve of the Earth. I was cresting the curve of the Earth. But it's only when you zoom right in and you realize, well, actually, there's a band of opaque, mirroring, refracted stuff that's on the horizon that's stopping me from seeing behind it. Because this mirroring stuff is opaque. You can't see through it. It's not translucent. It's opaque. It's effectively a brick wall. I don't know what causes it, how it causes it, or why. But I do know that when you see it, anything that's behind it, you cannot see anymore for whatever reason. So, and I'll show it. I'll show it with the 200 mil lens. I'll show the pictures I took, and you can clearly see that it gradually disappears from the bottom up. And when it does disappear from the bottom up, the only conclusion you can come to is curve of the Earth. But when I went back and got the zoom lens, totally different story. And I looked at it and I just thought, no way. So the moral of the story is, when you think you're seeing curvature, yeah, that's a fair assumption based on the tools that you've got. But if you go and put a zoom lens to exactly the same thing that you're looking at, it changes everything in terms of how you perceive the evidence, because the evidence itself changes. You get more detail, you can see more, and then you can, not only do you then get a different set of evidence that tells you new stuff, you then interpret that new evidence differently. So the conclusion of it is, if you ever see curve on a horizon and there's something that you think that supports curve, go and get a zoom lens, zoom right into it, and then see what you think you're looking at. Because it's crazy. The difference is crazy. If I didn't have the zoom lens, honestly, and I produced this evidence to say, look, there's definitely proof of curve, everybody would agree with me. They'd go, yeah, it is curved. The Earth is curved, because that's what the evidence tells you. But you can get better evidence with more zoom, and then that'll just literally change the way you interpret and perceive everything evidentially, because the evidence itself changes.
I mean, this is something you're going to actually publish in the next, hopefully today. I know you're not at home at the moment, so you haven't got all your facilities. But once that's done, Kristen's just asked in the chat, have you displayed the video yet? No, we're just discussing it at this stage because it's happening now. I mean, literally, Anthony's there taking these shots now. But it's exciting, and you've already got Gem Panda and Captain Bullshit in the chat triggered, saying that you're just looking for confirmation bias. And
no, not at all.
Anthony, I just want to say this directly to them as listeners. You know, Anthony, I've got to take my hat off to him. He's been extremely intellectually honest. So yesterday, his reaction, based on the information he had, was it seems plausible that this could be a ball. Not necessarily of the size that they tell us. However, he's gone back, he's made more observations, he's studied what he's got, and he's come to a different conclusion through greater study. And we're talking about zoom lenses. It's fascinating. Yesterday I watched Bling Bling BSS of the ISS on Patricia Steer's show, and she also has a P900. And when it came to this subject, it was dealt with in about 4 seconds. She said, yeah, I've got a P900. Yeah, it's just perspective. Conversation moves on instantly. You know, it didn't need any more justification. However, that's not to say that it's not worthy to figure out how it's been reverse engineered, and that's precisely what Anthony's doing right now as we speak. But yes, to answer Kristen, yes, you will get footage from Anthony. He will upload it onto his channel, Anthony Riley YouTube channel, as soon as that's done. But in the meantime, this is happening now. So as much as we'd like to have things instant, it's not as instant as that, unfortunately.
And just addressing Gem Panda, confirmation bias isn't based on evidence. Confirmation bias is based on your own perception. The perception based on the first set of evidence I got was that there does seem to be curve. So I went back and I got my zoom lens and I zoomed right into the turbines and I zoomed right into the land, and I could see why I perceived that it was curvature of the Earth initially. Now, confirmation bias is where I choose to do nothing about it and dismiss it and don't tell anybody it exists. That's confirmation bias. It's cherry picking, and it's essentially dishonest.
That's a reporting bias.
Yeah. So if I found evidence that was contrary to my own opinion, then I would just not tell anybody about it. That would be biased. That's cheating. However, I found information that went against my views and perceptions, and I shared it straight away because I wanted flat earthers to discuss it with me. And I actually spoke to ball earthers about it to see what the perspective would be. I then spoke to flat earthers about it to see how it could be explained. And the conclusion was, take your lens back, take your big lens back and go and see what you're looking at, because you'll get more info. So I did. I took the big lens back, went back to see what I was looking at under heavy zoom conditions, and then realized that there was more to the story than meets the eye. Literally, more to the story than meets the eye. Whatever met the eye initially was one story, but when you zoom right in on it and you can then see more, you get more answers back, and that tells you that it's not confirmation bias, it's just changing the evidence based on better tools. So it's nothing to do with confirmation bias. If anything, I'm being totally intellectually honest. Otherwise, if it was confirmation bias, I'd have said nothing. I'd have thought about it and thought, shit, maybe it is a ball. I'm not going to tell anybody about this, and nobody knows it exists. But if I went there and changed the evidence by getting a zoom lens, it changes the story. So you can't say it's a confirmation bias issue, because it isn't.
Now I'm going to take you on a little story here, so bear with me. About maybe 18 months ago, the very first time I interviewed Jaron Campanella, I explained to him that he has a huge amount of power based on the research he's doing and the things that he's uncovering. And over the course of about 12 months, he's slowly come to the realization, and this is no knock on Jaron Jaren. It's basically pointing out something that will make sense for Anthony in a minute, right? So Jaren has understood with, I think the best example was Stellarium. So you're showing a massive timeline that you could go through on Stellarium, looking at the pole star and seeing no difference. And then as a direct consequence of that it got changed. The timeline was brought right down so that you couldn't see that apparent change that should not happen on Stellarium. Now, yesterday, when Anthony and myself were chatting, he explained a concern that he has. And this concern is something that I describe as a heliocentric layer of bullshit that gets smeared on top of any very obvious flat earth proofs. And for anyone, like we've said a few times now, if you've got a P900, you're probably rolling your eyes now going, yeah, it's obvious. But for others, it's not so obvious, especially if you're still living on the globe. But there is definitely, right back to Robotham, you can look at the stuff that he has done and then see the layer of bullshit that's put on top of it. And if you were in a courtroom, it would absolutely be taken as globe Earth evidence. Therefore, the preponderance of evidence is actually for the globe on paper. Now, I know you know where I'm leading you here, Anthony. So, you have been dealing with a certain website called Metabunk, and they have taken what is the standard curvature calculation and factored in some other stuff. Maybe you could tell us a little bit about that.
Yeah, I mean, I've been dealing with Mick West from Metabunk, and essentially what I've realized is that when you have a vertical structure in the water, tides are an important thing. Tides literally influence that which we see optically. But on the Metabook website, there's no adjustment based on tides. Yet it's absolutely paramount that it's there. So they make the adjustment for the curvature of the Earth and the standard refraction, right? But there is no variation with regards to the tides. And it's because we don't really do observations with vertical aspects in the sea or in the ocean. But when you have a vertical aspect, tides instantly become important because it changes that which we see. So what's going to happen is at some point, when I release this footage and I show the difference between the two observation points based on high tide and low tide, the only one conclusion that you can come to is that we are looking at a direct contrast with the high tide and the low tide. And Metabunk website is going to have to accommodate this because it's evidentially true. High tide and low tide make a big difference on what we see if there's a vertical aspect in the sea that you're looking through or the ocean that you're looking through. Trouble is, they're going to make the change and then effectively patch up the hole in their system that makes anybody that goes to that site thereafter consider the position, because previously and right now it doesn't exist. But when you realize that it's an important variation and an adjustment that does need to be made to patch over the failings of the Metabunk website, then you realize that it's not going to last for much longer. So I reckon in 2 or 3 months' time, the Metabunk site will change and there'll be some kind of calculation based on the tide, because it definitely does change what we see. But I mean, obviously, heliocentrists would argue that that's because of the curve of the Earth and no change will need to happen. But not when you see the evidence that I've got. When you see the evidence I've got, you'll realize that it's not the same thing. It's very, very different, and it's going to have to account for it, patch over the gap in the work, and then people that come to Metabunk in future, they'll not even know that this conversation took place. So essentially, all I'm doing really is reinforcing and smoothing over the heliocentric failings, so that future people don't realize that there was ever a problem and they just trust it. But yeah, it's going to have to change because tides do make a big difference to what we see.
So like with Jaren's Stellarium, where he's finding out that there's an obvious problem, that problem is then addressed, and then obviously he still has his show pointing out that they've literally changed it based on what he's pointing out, but it doesn't alter the fact that anybody who comes to that software and checks thereafter still is met with the same, what was the word to use? The confirmation bias. What a shock. When they go to look at that. And this, you're saying, although it is a bit tricky to phrase this, I know we had the conversation last night, because it's hard to say, you're almost preemptively accusing Metabunk of doing this, and that's not what you're doing. You're essentially saying that this is a real observation, this is something that happens in reality, and if they are to be intellectually honest, in fairness, they would have to incorporate this into their maths, ball or flat, because they're saying it's a ball and this does happen, therefore they have to factor it in. However, the concern is that, again, for anybody who goes to that and looks at it, and then goes and makes the exact same observation as you, are led down a a conclusion path by Metabunk, using information which has been initially by you used to debunk their nonsense.
Yeah, and the problem is because they don't realise that it was an argument or a discussion point at some point in the past, they go in it at the premise that it's a ball. But the reality is, they're not going to know that it was never a ball in the first place. They're just going to see that, oh, well, if I put these figures in and get these figures out, oh, yeah, that matches the reality. But actually, what Metabunk should be doing is saying, yeah, you're altering the parallax between the waves in the foreground and the thing that you're looking at in the background, and swell is an issue. But does it mean that we live on a ball? Well, no. Does it mean that we live on a flat? Well, yes, it does appear to be the case. That does appear to be what we're looking at. It doesn't appear to support the ball at all. And I'm not preemptively accusing them of doing whatever, but what I am saying is that there has to be some adjustment for a direct variable in the atmospheric observations that we perceive, because the tide is making a big difference. It is changing what we see optically. There's no adjustment for it on the Metabunk site. There's going to have to be at some point, but the Metabunk website is doing it based on it being on a ball. But actually, I think they're just they're fudging the maths. They are fudging the maths to fit the evidences that we can achieve. That's what they're doing.
Yeah, so to anybody who joined us and was concerned that Anthony had defected to the globe, initially he was just being intellectually honest, and it would appear all is well. The Earth is still indeed flat.
Nathan, I have to go because I'm literally being kicked out of this place now because it's the end of my tenure, so I've got to go, but I'll speak with you soon.
It's been an absolute pleasure. Gives me a nice opportunity.
No worries, I'll see you.
No, you go ahead. Thank you very much for joining me, Anthony. It's been a real pleasure.
I'll speak to you soon, mate. Bye for now.
And again, that's a good opportunity for me to round out, as I think we'd covered all the points that we'd actually wanted to cover. So to all of you who have joined us in the live chat, thank you ever so much for being here. I've been Nathan Oakley. I'll see you all in the next video.